Look up at the sky right now. See that cloud? The fluffy white one drifting lazily across the blue. It weighs more than 100 elephants. Stop, read that again. That puffy, innocent-looking cloud floating above your head right now is carrying over 1,000,000 pounds of weight. Some of the bigger ones carry millions of tons. And yet there it is, not falling, not crashing down onto the rooftops below, just sitting there looking like cotton candy someone tossed into the atmosphere. How is that possible? The answer changes the way you see every cloud in the sky for the rest of your life. Let's start with the numbers because they're almost hard to believe. A typical cumulus cloud, those are the flat-bottomed, puffy-topped clouds you see on a nice day, weighs roughly 1.1 million pounds. That's about 500,000 kilograms. A fully grown African elephant weighs around 12,000 pounds. Do the math. That one ordinary cloud sitting overhead outweighs roughly 90 elephants stacked on top of each other, and that's a small cloud. When a cumulus cloud grows into a cumulonimbus, one of those towering dark storm clouds that blocks out the sun, its weight can easily exceed 1 million tons, sometimes several million. If a cloud that size could somehow lose its grip on the sky and fall all at once, it would hit the ground with the force of a small mountain collapsing. So why doesn't it? The answer starts with understanding what a cloud actually is, because a cloud is not a solid object. It's not a balloon. It's not a piece of foam floating up there. A cloud is a massive, sprawling collection of tiny water droplets or ice crystals, suspended in air. Each individual droplet is incredibly small, about 10 to 20 micrometers across. That's smaller than the width of a human hair. You can't see a single cloud droplet with your naked eye. What you see when you look at a cloud is billions upon billions of these droplets packed so close together that they scatter sunlight and create that white, fluffy appearance. But here's the thing that makes the weight so counterintuitive. Those droplets are spread out over an enormous volume. A single cumulus cloud can stretch across several cubic kilometers of sky. The water inside it, if you collected every drop, would fill roughly 500,000 liters. That's enough water to supply a small town for a day. But all that water is distributed across such a vast space that the cloud as a whole is actually less dense than the air surrounding it. That's the secret. That's why it floats. A cloud doesn't stay in the sky because it's light. It stays in the sky because the air beneath it is denser. Think about it like this. If you drop a rock into a lake, the rock sinks because it's denser than water. If you drop a piece of wood into a lake, the wood floats because it's less dense than water. The exact same principle applies to clouds. The air inside a cloud, a mixture of dry air and water droplets with lots of space between them, is lighter than the surrounding atmosphere, which is just plain dry air. The denser air below pushes up on the cloud, and the cloud rises or stays put. This is buoyancy. The same force that keeps boats on the surface of the ocean keeps clouds in the sky. But how did all that water get up there in the first place? It starts with evaporation. Every second of every day, water is evaporating from the surface of the earth. Oceans, lakes, rivers, even the sweat on your skin, water molecules are constantly breaking free and rising into the atmosphere as invisible water vapor. Warm air rises and it carries that vapor upward with it. As the air climbs higher, it cools. And at some point, the vapor reaches a temperature where it can't stay a gas anymore. It has to condense. Condensation doesn't happen on its own, though. Water vapor needs something to cling to. In the atmosphere, those somethings are called condensation nuclei, tiny particles of dust, pollen, sea salt, pollution, even fragments of bacteria that are floating in the air. The water vapor molecules cluster around these particles, and just like that, a cloud droplet is born. Multiply that process by billions, and you get a cloud. In 2005, researchers at NASA's CloudSat mission launched a satellite specifically designed to look inside clouds using radar. What they found was staggering. Cloud structures that looked simple from the ground turned out to be incredibly complex inside, layers of droplets at different densities, ice crystals forming at different altitudes, and water content distributed in ways nobody had fully mapped before. CloudSat measured the water content of clouds from orbit and confirmed the numbers that meteorologists had been estimating for decades. A modest cumulus cloud contains enough water to weigh over 1,000,000 pounds, and it just sits there, held up by nothing more than the physics of air density. But what about storm clouds? Those towering, dark, angry-looking clouds that bring thunder and lightning and torrential rain. Those are a different story entirely. A cumulonimbus cloud can tower 12 to 16 kilometers into the sky. That's higher than most commercial airplanes fly. It's a vertical monster, a column of moisture and energy that builds on itself as warm, moist air rushes upward. And as it grows, its weight skyrockets. By the time a storm cloud is fully developed, it can contain several million tons of water. Millions of tons. So how does something that heavy stay up? The answer is wind, specifically updrafts. Inside a large storm cloud, powerful columns of warm air are constantly rushing upward at speeds that can exceed 100 miles per hour. These updrafts act like an invisible conveyor belt, physically holding the cloud's mass aloft. The cloud isn't floating anymore. It's being held up by a continuous upward blast of wind. And this is precisely why thunderstorms are so violent. A cloud that weighs millions of tons requires enormous energy to keep from falling. When that energy becomes unstable, when the updrafts can no longer support the weight, the cloud releases everything at once. Rain, hail, lightning, downbursts of cold air that slam into the ground. In 1999, a study by atmospheric scientist Carrie Emanuel at MIT examined the energy dynamics inside thunderstorms and found that a single large cumulonimbus cloud can release energy equivalent to multiple nuclear weapons over the course of its lifetime. Not because the cloud is explosive, because it's holding back millions of tons of water against gravity, and when gravity wins, the release is catastrophic. Now here's something that might blow your mind even further. Clouds do fall all the time. When the tiny droplets inside a cloud collide and merge with each other, they grow larger. And once a droplet gets big enough, around 2 millimeters across, it becomes too heavy for the updrafts to support and it falls. That's rain. Every raindrop that hits your window started as a cloud droplet 10,000 times smaller. It grew inside the cloud, got heavy, and dropped. So in a sense, clouds are constantly falling. They're just constantly being replenished at the same time. And sometimes rain falls but never reaches the ground. Meteorologists call this phenomenon virga. You can see it in dry climates, those dramatic streaks trailing from the bottom of a cloud, looking like the cloud is unraveling. The rain is falling, but the air below the cloud is so dry that the water evaporates before it hits the surface. The cloud is literally losing its water to the sky, and nothing makes it to the ground. There's a reason this cycle never stops. It's called the water cycle, and it's been running on this planet for billions of years. Water evaporates, rises, condenses into clouds, falls as rain, collects in rivers and oceans, and evaporates again. Every drop of water you've ever drank has been through this cycle thousands of times. The water in your body right now might have been part of a cloud above the Sahara last month, or rain falling over the Pacific a century ago, or ice locked inside a glacier for 10,000 years. And here's the part that really gets me. The next time you're outside on a clear day, and you see a single white cloud drifting across the sky, looking peaceful and weightless and completely harmless, remember. That cloud contains more water than you will use in your entire year of showers, dishes, and drinking. It weighs more than the animals at a full zoo. It's being held up by nothing more than the fact that warm air is lighter than cool air. And if those conditions change, if the air cools, if the updrafts weaken, if the droplets grow too large, that cloud will release every ounce of its million-pound payload onto whatever is below it. We walk through our lives looking up at clouds and seeing fluff. We see shapes. We see cotton candy. We don't see a million pounds of water defying gravity through nothing but the invisible physics of density and temperature. But that's what's happening, every single time. The world above your head is not empty. It's full of weight, full of water, full of energy, held in place by rules so simple a child could understand them, if someone bothered to explain. Now you know, and the sky will never look the same.